Okay, so question 6 is a critical path analysis question, and it's all about different tasks that need to be completed for a proposed ticketing process for a concert that's coming up. The time taken to complete the task is not on the network, and as we work through these questions, we're going to be filling in some of these examples in Part A. In Part A, we will start with B and want to know how long does it actually take to do B, and so we're interested in doing the 7 take 3. Which is going to give us 4 weeks to complete task B. And we're going to do a similar thing over in F, where we've got the 10 and the 17 here. And so to complete task F, it's just going to be equal to 17 minus 10, which is just going to be equal to 7 weeks to get task F completed. Now, hidden here in this line here is something that's quite important. We're saying that task H has a 1 week of slack time. So over in task H, which is just here, it means that this 17 that we're looking at, that's the latest start time for task G, but not H. So what we need to do is on this network, we've got to add an extra week to the latest start time for H, so that we'll put an 18 there. So then when it says, well, how long does task H take, then when we go to do this calculation, it's now going to equal to the, that's not a 21 minus 18, which is equal to your 3 weeks. Okay, so that slack time there is actually quite an important piece of information. And it's also relevant here to us trying to find the critical paths. Now, it does have an S here for the paths, and it also is worth 2 marks. So we are essentially looking for 2 critical paths through this network. And I'm just going to change my highlighter here. So A and B has to be on the critical path because it's the only way through, it's the only way through this network at the start. And then we're going to go up through C because we've got the 9 and 9 here, and then down to E. Now we can't go through H here because we were told in the question that it does have 1 week of slack. So we're going to go up to G, and then we'll go through K as our first option. Now the second option here is up for us to be able to use this dummy link and go down to go then through J. So we start off the same, and we're going to go B, C, E, and we're still going to go G, but then we're going to go down through the dummy link and then up to J. So they're going to be our 2 options that we're going to write down there. I think they both started with A, B, again, because there's no other options. Then C, and we'll go GK, and then we'll go A, B, C, E, we'll go G, and then J. Now, just to note here, it says that when we do a backward scan, we take the smallest number. So this one here, this J, to get to J, it had to be 24, take 21, which equals 3 weeks to do task J. Now K, because it's a backward scan, we take that smallest number. We've got 2 numbers that we have to consider. We have to consider what's coming back through J, through the dummy link, but we also have to consider K. If we're putting the smallest number in there, it could be the 21 that goes in, but K can also take the values of 1, 2, or the 3. If it's a 3, then it's the critical path that we've just selected. So something for us to think about. I think the solutions say that they would accept just the pink as the only answer there. But for 2 marks and the S, I would be giving 2 critical paths. Now, state why task A and task B must always lie on all critical paths. I think I kind of mentioned that earlier, but it's because there's no alternative path available. Okay, so I'm just going to say no, alternative. We can say parallel in there, parallel path available. All paths must then include A and B. So we'll go with that. So now we're looking at a rival agency ticketing agency here. And we just have to complete the forward and backward scan for this task. So we'll start with our forward scan. So we're missing a number up here. And in order to get that, we're going to add 2 plus 3 to get 5. Coming down into E, on a forward scan this time, there's 2 options to go into this node. So we're always looking for the biggest. So 6 plus 4 will be 10 as an option, or we've got over here to say 5 plus 6. And because 11 is bigger than 10, we're going to put 11 inside the node as the EST. So remember the EST, or the earliest start time, is on the left, and then our LST, or our latest start time, is going to be on the second half of the node. We've got one more node to go for a forward scan, and there's only one input here, so it's going to be 11 plus 3, which will be 14 as the earliest start time for task N. Then we switch, so I am going to switch colors here. So we're going to go on a backward scan now. So this is the first number that we want here, and with a backward scan we look at the back end of the arrows, and we're looking for the smallest number to go in. And we're going to choose between 18 take 4, which is going to be 14. So we'll put that on the outside for now. And then we've got 16 here, take 5, which is going to be 11. And 11 is going to be the smallest of those 2 numbers. The other one stays out on the outside here because that's your latest start time, for J. Okay, whereas the number in the node is the latest start time for K. Keep coming back here. For G, we now have 11 minus 3, which is going to be 8. There's only one back end, so there's nothing else to consider going into that node. And then up though, we now have these 2 to consider. We want the smallest one coming in. So remember, a dummy link is essentially has a 0 task time there. So 8 take 0 would be 8. And I'll just get rid of that for a sec. So we're going to choose between 8, and then we've got a number here that's saying, well, what is 14 take 4, which is going to be 10, and the smallest of those numbers is the 8. So the 8 is going to go on the inside. And that's it. So that's us here, my yellow, completing the forward scan and the backward scan to fill in those missing values. In part E, it's saying what is the latest starting time for task B. So if we come back up here to our network, we've got B on a different color again. So we've got B coming in here. And remember, if we were working backwards from here, would say that we've got 8 minus 3, which is going to equal 5. And that's going to be, and that didn't actually get into the node because it's not the smallest number, right? So 8 here takes 6 is going to be the 2, and then 8. So, and that's the smallest one of all those 3 options to get inside the node. So that 5 is going to be our latest start time. So our LST is equal to 8 minus the 3, which equals 5 weeks. Or 5 weeks into the starting thing. Now there's going to be a little bit of a change, it looks like. So it's saying it's underestimate the time taken to complete task J by 4 weeks, and then given this new information, provide some evidence to say which ticketing agency should now be used out of A and B. So we're going to come up, we might have to scribble on this network a little bit. So we're changing task J to take an extra 3 minutes, and we might need another color pen. So task J is here. I'm just going to get rid of that 4. And now it's going to be taking us not 4, but we're going to have 4 plus 4. So it's going to take 8 weeks now to complete task J. So as we come and look at the forward scan changes here now, it's going to be 11 plus 8, which is now going to be equal to 19. And then that affects the finish time maybe, because now we're going to have 19 plus the 4 weeks for L, which is now going to be equal to 23. And because we want the largest number on that left-hand side of the node, it has to be the new finish time for this network. So changing that definitely affects the minimum completion time. So I'm going to say something like increasing J to 8 weeks. Oops, sorry, 8 weeks means completion time for agency B is now 23 weeks. So using B is faster than A, which I think it took 24 minutes earlier, but we'll just have a quick look back here. I think we're actually given, yep, so there's the 24. So agency B is still quicker, even with those changes that it just had to make to task J. And that's it for question 6. Question 7 is a linear model question, and it has residual calculations throughout as well. So this question starts with a lot of information at the start. So with our highlights, it'll be best to pull out the important bits involved. But there is a study that was conducted that looks into the relationship between public health expenditure as well as how happy the country's citizens actually are. The two data sets that they used to get that information was using a percentage of the GDP for a country. And then for the happiness, there was they collect a score out of 10 to measure the citizens' happiness, I guess. Just let me change my pen. All right. So given that, they've got a table that shows the data they collected for these particular countries, and then also they've got that same set of data into a scatter plot below. On the next page, what we're actually asked to do with this data is to find the R value for the linear model of that data set, and then they actually want to know what is the model as well. So we have to get this stuff into our calculators. We're going to be doing that in the statistics menu. So if you go menu and then number 2, you can see I've already pre-entered the data, but the GDP essentially is list 1, and then the happiness index is going to be list 2 here. Just have a look at a quick graph, a quick scatter plot of your data. Okay, it should be looking something similar to what the one we're actually given to us on the first page. And then from here, you can see there's the option for calc. So we're just going to go into calc. We want to use the x or the linear function, which is F2, and then F1 to go AX plus B. And we can see from that information that R is going to be equal to 0.921. And we always use 3 sig figs for our R and our R squared values. Now, our linear model is going to be y is equal to ax plus b, and then from our calculators, we can see in this case that a is equal to 0.282, and then b is equal to 4.564. So we're going to have a look at our 3 options here, and we can see that it's going to be the third one that matches our calculator output. And it's asking us to, now that we've selected one of the 3 models above, to interpret what the 4.564 means in the context of the question. Now, the 4.564 is the y-intercept, 4.564, but just saying that's the y-intercept is not the context. So the context is us saying that a y-intercept is when x equals 0, and in our case, the x value is the GDP. So a country that spends 0% of GDP, I might have to come over here, on public healthcare would have a happiness index of 4.564. I'm just going to fix up my form. So that's the interpretation of what that y-intercept actually means for 1 mark. Now, they've given you in the next graph an actual residual plot for all our data, and they're telling you that one piece is missing. And so in part C, it's like, well, can you add that missing residual value? Now sometimes it gets a little bit hard to actually figure out what this is, but you can it's normally going to be one of the end ones if you're lucky. So we can see here that our smallest value is at 3 and our largest value is at around 8.5. So when we go back up to the table, we can see here that there's our 3, there's our 8.5, and there was nothing past 8.5 in the graph. So it looks like the one we're missing is Sweden. So 9.2 and 7.34. Now that's not the data that actually goes in the table. Although having said that, it is actually the X value that we're looking at here. Now, before we go to calculator, just to note, it is a residual value, and the formula for the residual is equal to the Y observed, which is what we've got in the table, minus the Y predicted, which is what we're going to use up here, which is our H equation in part B. So to get this in the calculator, what we're going to do is we'll just press exit. We're just going to go to our list. Now in list 3, we want to actually enter that H equation. So it's going to be, and have your cursor up over list 3, so 0.282 times the values that are in list 1, and then we're going to plus 4.564. Okay, so that's filled that up, and that's there now. Our, if I put that in, that's going to be our predicted, so that's in list 3. Our observed is from the table, so that's in list 2. So now what we're going to write over in list 4 is we just want to do list 2 minus list 3. And we only really care about that very first one. So the residual now is equal to 0.18. Well, that's enough to graph it. So it's going to be 9.2 and probably about here. So 9.2 and 0.18. And let me fix up that 0. Okay, down in D, it's saying, okay, use your answer to part A. Now in part A, we've got R is equal to 0.921. So it was our Pearson correlation coefficient. It says use that and use the residual plot to give 2 reasons. So it essentially wants a reason for each, why the linear would be considered the most appropriate. Now, firstly, we'll go with the R value. That's a pretty good R value. In fact, that shows a strong linear relationship. Now, looking at the residual plot, when you want an appropriate linear model, you want your data or your residuals to be random, and that's exactly what you've got up there in the plot above. So you just want to say something like the residuals, and it's got to be the residuals, because you remember you've got 2 graphs. You've got a graph back on the previous page that shows the actual raw data, and then you've got this one is the residuals. So make it clear you're talking about the residuals. So the residuals are randomly scattered about the horizontal axes. And that should be enough for 2 marks. Now we get to actually use our equation. So remember, I'm just going to write up again because we keep coming back to it. 0.282p plus 4.564. So we're going to use our linear model, and we're going to actually do some predicting now. So we've got another country that was not in the original table that has a happiness index of 4.02, and we want to know, well, what are we going to predict for their percentage of GDP? So we're going to have 4.02 is equal to 0.282p plus the 4.564. Now we're going back in here. I'm going to use my solve n. So option, I'm going to go calc solve n, and I'm just going to type this in. So 4.02, the equal is where the decimal point is, 0.282x plus 4.564. Okay, let's see what we get. That's not what I want, but it is that first number there. It's got it as a decimal and a fraction. So we get that p is approximately equal to minus 1.93. and it's a percentage of GDP. Now, that answer is a little bit unusual because in the context of the question, what does it actually mean? Well, it means you're spending a negative amount of your negative percentage, of your GDP, which is not quite possible. So no, not reasonable. Since you can't spend a negative percentage of GDP. So we go again. So this is another country that wasn't on the original table, and they say that Finland spends 7.3% of its GDP on public healthcare with a happiness index of 7.8. And this one here, we're actually asked to find a residual value. Now, remember what I said before, that the residuals is equal to your y observed minus your y predicted. Oops. Now, the y observed is your 7.8. Okay, so that's this guy here. And your y predicted, if I can fit it in here, is going to be what happens when Finland has 7.3 of its GDP. So it's going to be the 0.282 times the 7.3 plus the 4.564. So 0.282 times 7.3 plus 4.564. And in this case here, we get 6.6226. So now we've got enough information to put both of these into this formula. So it's going to be 7.8 minus 6.6226. And our residual is 1.118. Oh no, sorry, got that wrong. 1.18 maybe. Okay, and then that's it for this question. Question 8 is a financial modelling question, and we're going to compare two different strategies for investing some money. And the two people that we're going to be looking at as we go through are both Janet and Bill, and they're twins and have just sold a truck business, and they've each got $12,000 to invest. Now, Janet is the one we start with, and she's going to put her money in the bank to earn interest, and her options are kind of given in table 10 below, and we're asked to kind of fill in this missing effective interest rate. Now, an effective interest rate is an annualized rate, and it just makes us easier to compare different options when we have different compounding periods. So with this one here, we're just going to jump into our finance menu, and we're going to come down to conversion, which is F5, and this is where we're going to be entering stuff. So our N in this case is just going to be how many times we compound per year, and it's going to be equal to 2, and it's a 4% interest rate. So when we press effective here, we're going to go with 4.04. And what we inputted was 2.4 here. Now, the hence state which of the compounding periods would be the most financially beneficial. So because she's investing money and trying to earn money, we want the highest amount, and that weekly one is definitely the highest interest, or highest effective interest rate. In table 2, she's also looking at some options, and she's got 4.5%, but this time it's a flat interest rate, and they've done a little bit different in the graphics calculator. So when we look at the graphics calculator this time, the N is going to be, because it's a 10-year, it's going to be equal to 1 divided by 10. So it's 1 on N essentially. And then we're going to pass in the 4.5% interest. Flat rate interest. So effective rate, and so we're going to have 3.78 or 86. So we want to use 3 decimal places because that's what the rest of the table has used. So we're just going to have some consistency there. Okay, on the next page, we're still looking at Janet. And with Janet, she's decided on two options. So one is just a compounding monthly one at 4% per annum. The other option she's got is a flat rate, so essentially a simple interest rate. And we've got in part C a show that question. Maybe I should highlight that. A show that question, and it's approximately $50 difference in what she will earn. So if we need to essentially calculate interest she's earning for A, the interest she's earning for B, and then find the difference between the two. So I've kind of set us up for A first because it's a compounding interest question. Now, remember it was 5 years up here, so it's 5 times 12 because we're compounding monthly. It was 4% per interest per 4% interest per annum. Our present value is the $12,000. Our payments, well, there's nothing else that she's putting in there, and we want to find the future value. So we're on the calculator. We'll get out of here. Go back to compound interest, and we'll start putting in these numbers. So 5 times 12, 4% interest, negative 12,000. 0 payments. Future value is what we're saving. We can see we're compounding monthly. So if we do future value here, actually we don't even need future value. What am I saying? We're going to use the amortization option because it's easier for us to do sum of int, and we're going to do sum of int up into 60. So the end of those 5 years. That's easier. Okay, so the sum of int is equal to 2651.96. So $2,600 51. Now B, like I was saying before, simple interest. So I is equal to P times I times N. The principal was the 12,000 timesing by this case 4.5%, so 0.045, and for 5 years. Let me just quickly put that in. Okay, so 2,700. So the difference between these should be around $50. So therefore, it's equal to 2,700. Subtract the 2,651.96. 2,651.96, which is $98.04, which is approximately the $50 as, whoops, ran out of space, as required. Perfect. Okay, then we move on to Bill, and this is what he's decided to do with his $12,000. But before we get to that, we're just considering his home loan first. So he took out a home loan 6 years ago to purchase his property. He borrowed $510,000, and he's paying 6.85% per annum, compounding monthly for 30 years. And he's making minimum monthly repayments of $3,341.82. And it's saying it's another here, we've got to show that question. So it's going to be close to the $472,000. Hopefully the balance is after 6 years. So again, 6 years, so and compounding monthly, is that 72? The interest rate was 6.85. The present value is his loan value, which is $510,000, and it has to be positive because the bank's giving him the money, and he's paying $3,341.82. So that has to be a negative amount, and hopefully that balance will be what we're after. Okay, F2. So 6 times 12, 6.85. 510,000 negative 3,341.82. Okay, and we're trying to find the future value. So when we solve for that, the future value is equal to 471,790.75, which is approximately equal to the $172,000 that we're asked to show. So the interest paid over that time period is just going to be a sum of int. Again, it's only 1 mark, small amount of space. So PM1 is what we have to enter, and PM2. So we're starting off right at the start. So we press amortization back on our calculator, which is F4. And we're going to go from 1 to 72, and which is PM2. And so the sum of int here is going to equal 202,401.79. So that's how much interest he's paying in those first 6 years. Now, after those 6 years, he's actually that's when he gets his $12,000 payout, and he's going to put that into an offset account. So the new balance of that offset account is just going to be the other one we just found above, reduced by $12,000. So it's 471,790, and there's 75 cents minus the 12. Okay. 471,790. Oh, sorry. Don't know what happened then. So we've got 459,790.75. So $459,790. Okay, then Bill is going to go on and he's going to calculate the loan if the 12,000 is left in the offset account for 10 years from now on. So back over here, I've kind of it's going to be another 10 years, so 10 times 12, it's the 6.85. We just found the balance was 459,790, and I think there was 75 cents there. He's still paying the 3,341.82, and that's still going to be negative. And the future value is what we want, and this is monthly compounding. Okay, compound. All right, so it's 10 times 12. 6.85 doesn't change with the balance. The present value does though. It's 459,790 with that 75 cents. And the future value is what we're about to find. Okay, so it turns out that he has 336677.01. So 336,677. Okay, now after that 10 years, Bill was withdrawing $7,000 from his offset to pay for some renos, and we're saying, okay, now calculate the total interest that Bill will save over the term of the loan by using his offset account. So I've kind of pre-filled some stuff here. Okay, so what I've put in here is this is the balance that we found above, so the 336677, and then I've added the $7,000 because that's the amount that he's withdrawn from the account. So essentially his balance now has increased by that $7,000. So we'll go and see if we can't see what that means in terms of how long it's now going to take Bill to pay off his loan. So N is what we're trying to find here. We just have to adjust my future value because we're paying off the loan, as you like. Then we find N, and we see that we're going to have N here is equal to 155.38. Okay, so that's how long it's going to take him to pay off the rest of the loan at the end. Now, we have to still find out the total interest, which is still requires a few more calculations. So the original loan is equal to 360 months because that's 30 years. Now, the time saved here is going to be the original 360 months that Bill was expecting to pay off the loan. Now, we minus the first 6 years, which was 72 months. Then we minus the next 120 months, which was the 10 years that he had up here, that he withdrew the 7,000. And then we're going to take off the last 155.38 months, which is the remainder of his loan. So I think that ends up being 12.62 months that he saves. Which means that if that's the time saved, then the interest saved is going to be the $3,341.82 that he pays for those 12.62 months. And then we have to subtract the $5,000 or put the $5,000 in. That's the amount left. That's the he had $12,000 in the offset, and then he took out the $7,000. So that's what's left over in his offset account. And then that, if we just go over here, so it's 3341.82 times 12.62, take the 5,000. It's going to be 173, I should say, 0.77 is how much interest that he's saving. Okay, so a couple of steps to get through for that total interest. The last bit of this question is saying, well, why would Janet need to consider tax implications, but Bill doesn't? So I've kind of written it in and I've said, well, Janet, she put money into a bank account or a savings account, so she has to earn, and she earns interest, and when she earns interest, you've got to pay tax. So that's Janet. Whereas Bill, he's just got his money sitting in an offset account. It's not earning interest, it's just kind of reducing the balance of his loan, if you like. So there's no interest that he has to pay, and so there's no tax liability for Bill either. And that's the end of the final question.